Hello, and welcome to CFUV's Climate Jam, a series on exploring technologies that can be used to combat global warming. My name is Jason Grenier, and I am producing a series of interviews on solutions to climate change with the assistance from the BC Sustainable Energy Association. Their website, bcsea.org. Kermit the Frog said that it isn't easy being green. He even wrote a song about it. I think that my guest today, Rob Bernhardt, will argue that statement, especially when it comes to our homes. Today's topic is on zero net energy and passive buildings. I have on the phone with me Rob Bernhardt from Bernhardt Contracting to talk about new construction of such buildings. And next week, I will be speaking with Jack Meredith, president of Healthy Green Buildings, to talk about retrofitting existing homes and turning them into passive or zero net energy buildings. Rob, thank you for joining us today.
My pleasure, Jason. Thank you for having me.
Could you tell us about your company and what you specialize in?
Well, we're a small general contracting company in the Greater Victoria area. I do project management with the company, and most of our work is actually commercial construction. But we have an interest in high-performance buildings and decided that we would build a residence.
And this is a passive building design?
That's correct. The concept of the passive house standard really attracted us as builders. It just made all the sense in the world to us because it is science-based and economically driven. We have a great interest in doing this in larger buildings, multifamily buildings, commercial, institutional, that sort of thing, where actually the standard is easier to achieve. The residential context is where it is more challenging than in larger buildings. So we thought we would do this project as a learning experience and to demonstrate the affordability of the standard.
Excellent. Can we get some terminology down here? Could you define a passive building and also define zero net energy buildings?
Certainly. When someone who is trained in passive house design uses the term passive house, they're referring to a specific international energy efficiency standard for buildings and for all types of buildings, not just residential. And so that's what I'm referring to when I say that. And that standard is one developed in Europe and that is now the building code in many parts of Europe and will become the building code throughout Europe in the not-too-distant future. And it sets very, very stringent energy consumption standards for buildings so that for the most part a building can be heated without installing a separate furnace, for example. You do have a heat source, but it's efficient enough that you don't incur the expense of the larger mechanical and heating systems that we traditionally have put in buildings. So that's the idea, and it connects with the net zero in the sense that you don't bring the energy consumption down to zero, but you bring it as far down as it can be economically done, and then the balance, which is actually about 10% of the heating energy of a traditional building, can be very, very easily met through renewable energy sources or whatever means you would choose to use. But it economically eliminates about 90% of the energy consumption of a building and then leaves it up to the building owner how the remaining 10% ought to be met. So in our view, it's the most economic avenue towards achieving net zero because there's very little incremental investment needed in renewables in order to meet the energy demand of the building.
Right, and you're building the first passive building in the Greater Victoria region, and it does reach the 80 to 90% energy savings. And that home was finished in...
We just completed it this spring, and I just finished today, in fact, putting together the last of the documents and so on required to apply for certification of the building as a passive house.
Could you tell us a bit about the house? I mean, how do you design a house with such high energy efficiency? You got to face it in a certain direction, and you got some super insulation, and you got special windows for these types of homes?
The concepts, Jason, are really quite simple. The detail can be a little more challenging, but the basics are very simple. To achieve energy efficiency, you begin, first of all, with a simple building form. And that means there aren't a lot of, wings and add-ons and juts, parts of the building jutting out. You keep the form as simple as possible so it's compact. So you minimize the area of the building envelope relative to the volume that's enclosed within the envelope. And then, as you mentioned, the orientation is a factor that is considered. Not that it's not as critical as people might think, because it's amazing how little solar exposure is required. But clearly, if you have a wide open south-facing exposure, it becomes easier because there is a lot of energy in the sun in the winter. And you try to orient the building and place windows and so on to take advantage of that. It varies with the site, but that is a consideration. And that combined, that simple form, try to sort of orient it towards the south to the extent possible, are two sort of fundamental components. And then over that, one designs a high-quality building envelope. So that includes factors that you mentioned, such as insulation. There's more insulation in the walls. Instead of a 6-inch thick wall, we have a 12-inch thick wall. And the windows are a higher standard. Now, the new building code has required the standard of residential windows to go up anyhow, but we're using windows that are much better than that. And by building in a way that it creates a very effective thermal envelope, and a simple form sort of faced towards the south, then you've got a building that requires very little energy to maintain. And that's really the key. The other required component is mechanical ventilation, and highly efficient mechanical ventilation. Because if you don't have a building that the wind whistles through, then you need to be providing fresh air to it, but you don't want to be losing all of the heat when you exhaust the indoor air. So that's what a heat recovery ventilator will do. It's just a very, very simple machine that pulls in fresh air and extracts the used air, but it transfers the heat from the exhaust air to the incoming air so that it isn't lost in the exchange. So the heat isn't lost in the exchange. Therefore, you've got superior indoor air quality and superior thermal comfort in the building. And that's really the essence of Passive House. It doesn't talk about what materials you use, how it should look, whether it's a colonial home, a modern home. It can be any style, any sort of finish, but it is built within a very strict energy budget, and a detailed energy model of the building is used to calculate the energy consumption during the design phase.
You answered the next two questions I was going to ask, but we'll keep going here. One other question, are passive buildings able to stay cooler than conventional buildings in the summertime?
That's an excellent question, Jason, because people are often concerned that they'll overheat, and in fact the opposite is the case. Another component of the Passive House standard is that they must remain cool in the summer. That's part of the certification criteria, and that summer comfort is obtained by ensuring that the windows that are exposed to the sun, or could be exposed to the summer sun, are shaded in the summer, but exposed to the sun in the winter. And that actually isn't difficult to do. Most architects, there's lots of design software that has programs available that show you exactly how long a roof overhang, for example, needs to be to shade the window. So those sorts of features are incorporated into the design of a building just to ensure that in the summer the windows exposed to the sun remain shaded, but in the winter they're able to take in the energy from the sun and are exposed to the direct sunlight. So if you've got shaded windows and a high-quality thermal envelope with good ventilation, the inside of the building actually stays relatively cool in the summer and is less prone to overheating than conventional construction.
Sounds pretty simple to me. Could you talk about the cost of building a passive home compared to conventional home? And also, are these homes, are they written into the Canadian Building Code?
Jason, if we just perhaps a few comments on the cost, first of all, because that was one of the characteristics of Passive House that attracted us to the standard as builders. Because in looking at the standard, we couldn't understand why it needed to be expensive. And we thought, well, let's build one and we can then illustrate the cost. So that's what we did. The envelope components that are of a higher standard than required by the building code are not that big a part of the construction cost for a building. And the windows certainly cost extra. There's additional insulation, that sort of thing. But those features aren't that expensive. They do add, but it's not astronomical. There's also additional costs incurred in the design of the building because a little more care needs to be taken and a little more thought put into how it's designed. So there are some incremental costs, but there are also significant savings. There should be no air conditioning, for example. There should simply be no need for that. The building that we just built has no furnace. It does not require expensive in-floor heating because the floors are warm, and they're warm simply because they're really well insulated. There's nowhere for the cold to get to them. And if one offsets the savings in the mechanical costs for things like heating systems and so on, heating and cooling systems, then the additional cost of constructing to the Passive House standard is really very small. And our experience, even with our very first project, is that the building is cheaper to live in from day one than a conventional building would have been. And we say that because the cost of construction was slightly more, but our living costs are dramatically less. And if we add the incremental construction cost to the mortgage, that additional cost is more than offset by the savings in energy and building maintenance. It's not just the energy of operating the mechanical equipment we're saving, or the energy of running the furnace we're saving. It's the cost of maintaining and replacing the furnace or the air conditioner or the in-floor heating or the heat pump and all these things that we don't need and that most passive houses don't need.
Yeah, this is the first green technology that I heard of that is actually not a lot more expensive than what we currently have. I mean, if you look at solar panels, it's quite expensive, but there is definite benefit, and even electric cars, same thing. So it's good it's important to educate the public about this. I think this passive house design is a no-brainer as far as what I hear from you. But what I think is even more important is to convince our MLAs about these technologies and that these technologies are the future. If you had the opportunity to speak in front of the government, what would you say to convince them to provide financial incentives to those who wish to build a passive home and even have the passive design written into the building code?
Well, Jason, the governments, I believe at all levels, have set out climate change objectives, and buildings are a very significant contributor to greenhouse gas emissions and to our carbon emissions. In urban areas, as I understand it, they're a larger contributor than transportation is. So if we are to achieve our goals at all, and the goals that have been set, then buildings must play a significant part of the solution. We can't get there without doing something about our building standards. So if that commitment is in fact there, something must be done. And this is an area where it's possible to make significant progress. The costs simply are not that great. Some will argue they are. I would suggest those that are arguing the costs are that great probably haven't built a certified passive house. But it is an option that's there for government, in our view, and we would urge them to do whatever is possible to make it happen. There may be incentives and other policies that don't cost the government anything. There can be modifications to zoning requirements and that sort of thing. And often it's a choice between some features that people may choose to put in a home or efficiency. For the cost of granite countertops, it's possible to build a tremendous amount of efficiency into a building. So often it's choices more than absolute dollars.
Okay.
And in other jurisdictions, governments have taken action. Certainly Europe is an example of that, where they've really made significant progress on some climate change objectives. And there has been incentives offered to the government, or simply regulatory requirements, where the passive house standard has effectively been incorporated into the building code in many jurisdictions. So those are the sorts of options that are out there.
Yeah, if you want to get motivated about this kind of stuff, definitely look at Europe. It's interesting to see that it's all coming out of Europe, and we're not doing nearly enough in North America. But that's all the time we have today, and I just want to thank you for joining us.
Well, thank you, Jason. It's been my pleasure.
All right, perfect.